Alright. TM5650 Essential Boiler Plans approved for public distribution eliminated. Six and three, Operation 49 Boiler Water Treatment Operation Log. Example of the monthly repairs operating with the local log boiler water operation log DA form 4367 is shown with the figure 421. Regulations require this log to be maintained with the plants operating with a 15 psi gauge with a steam and 300 psi gauge water with an output capacity of 3.5 million BTUs an hour, 100 horsepower. The log provides with a record of boiler makeup with the condensated water treatment with the test result. The data obtained with the log makes the accurately analysis of the plant operation possible. Entries are made with the columns of an explanation of the underneath each of the column in the back of the form. The log should be maintained each of the boiler one plant. Makeup of the water detail columns 19 and 20 may be used with the record. Condensating conductivity hardness of the boiler is secured with the wet condition caustitic and the solid phosphate. Residual should indicate the marks black. If the boiler is secure drive with the frequency disconnect and inspection should be inspected, organized. The operating log should also be maintained with a low pressure boiler for the hot water treatment, medium temperature treatment, and low water treatment. Logs should contain the following information: results for the chemical test, data of test performed, amount of chemicals added, date of chemicals added, the amount and time of the blowdown was formed, periods of the boiler layup, and the downtime maintenance should also be recorded. Alright, 410, procurement of the standard special treatment chemicals. Prescribed with the chemicals for boiler plant watering condition may be procured at least listed below. Caustic soda. Specified with the caustic soda with the boiler feed water treatment containing not less than 75% of the sodium oxide and be flaking in the form and absorb the moisture resumable ready and become sticky and specify shipment of the chemical for 100-pound steel drum. The chemical may be procured with the commercial source. Sodium phosphate may be specified with the reference table 4. For example, the sodium metal phosphate specified with the compound boiler feed water of the type of the sodium phosphate glassy 67% PTO B2O5 with the chemical ship with 100-pound bags may be procured with the federal supply schedule. Quay bracotanian. Specified quay bracotanian style with the boiler water heated condition suitable proposed to obtain the easily sellable should be the following composition. Shall contain not less than 65% of the Quabo-Atro-Tanian, not more than 70% of the non-Tanian, not more than 1% of the insoluble, not more than 20% water, packed in 100-pound bags. The chemical may also be procured with the federal supply schedule. Sodium sulfite. Special sodium sulfite and Na2SO3. Sodium sulfite anhydrous boiler feed water treatment containing at least 90% of the sodium sulfite, sodium carbonate, and lead with less than 1%, 10% sodium solution to alkaline phenylethylamine halene. Antiforms. Antifoam, other special water for the treatment chemicals consultant, the operating agency commander with the proper chemical to use the correct method of application. F. The rock salt. A good grade of the rock salt is preferably granulated with the salt and with the regeneration purpose. The rock salt does not cake, so does many of the grades with the grades granulated salt when it is equally effective with the regenerating agent. The salt should contain not less than 98% sodium chloride per minimum calcium magnesium salts containing with less than 1.5% dirt and other insoluble materials and have a grain size within 10 to 15% of the mesh range. Morpholine. Specified morpholine C4H9NO boiler feed water compound used to control the carbon dioxide corrosion steam condensated lines. 40% of that morpholine contents of all drums would be adequate with caution label to protect against fire, poison, and caustic burns. Hazardous packed in 480-pound drums, 55-gallon drums available for from federal supply schedule. Alright, cyclohexylamine. Special cyclohexylamines, carbon 6H11, hydrogen 11, and nitrogen and hydrogen 2. Boiler feed water compound used to control carbon dioxide corrosion steam condensated lines. 40% of the carbon cyclohexylamine content is all drums, but to the here adequate caution label to protect against the fire, poison, caustic burns, and hazards packed in 420-pound drums. 55-gallon drums, air packed with 40-pound drums, and 5-gallon drums available with the federal supply schedule. All right, I priority compounds. As general policy, use of the pre-mixed chemical compounds is not authorized. Such compounds, pre-portioned, course collectively in the specified water, generally cannot be used eventually without changing the water. Different analysis. If the boiler compound is fixed mixture of the chemical, there is no way to adjust the dosage of individual chemicals for remaining the desired concentration of each of the boiler exemptions. This is an automatic continuous blowdown control. Shows the continuous blowdown line going into the following a line of circuit of the manual bypass valve, and then going to having a butterfly valve before the butterfly valve for modulating control valve, which goes to control conductivity with a sensor. Also, the continuous blow line goes through a cooling water before the condenser sensor, and to a butterfly valve to the drainer sample. They also on the through the one continuous line of the before that goes the continuous blow line for the minimum bypass valve, or through the butterfly valves of the continuous blowdown line to the flash tank heat exchanger. Figure 420 shows the conductivity meter. It shows a repairs and utilities operating log. Alright, may be authorized off chief engineers. Also, exemptions are made with the priority of the briskets for the power plant water conditioning of the heater through the operations. J. Magnetic electromagnetic descaling devices. A variety of the magnetic electromagnetic devices currently manufactured claim to produce both corrosion scale and substantially no technical control. Several commercial units that were evaluated under field laboratory conditions. These tests do not provide indication the device is effective preventing of reducing a scale or improper boiler efficiency. Army-wide use of the magnetic descaler is not recommended based on these fitting findings. Moreover, the current operation of such device Army facilities should be quantified and validated. 411. Care mixing of the treatment chemicals. If the chemicals are received with the dry state, it must be properly stored to prevent contamination and absorption of the water. Precautions must be taken with the mixing and handling chemicals to ensure the accurate quantity of their use. Prevent contact chemicals which could cause injury. Storage. A. Store all the chemicals in dry places at the floor level, free of the contact with the foreign substances. B. General precautions as avoiding getting chemicals on the skin. Wear work gloves for the eye protection with the handling chemicals either in dry form of the solution. Add chemical solutions by the feeding of the device immediately after the preparation. The use of the properly designed screen to remove the foreign material from the solution from the feeding is desirable to prevent line stoppages. If the chemicals are as flaky, caustic contact with the skin, they must be rinsed in large quantities of water. If chemical solutions are splashed in the eyes, you rinse immediately with large quantities of water. Refer to Figure 418 for additional safety precautions. C. Method of mixing and making up chemical doses. Caution. Mixing chemicals at the floor level or an approved open feeder to avoid injury of the eye and face. Do not mix batches of chemicals advanced to the immediate requirement that defeats the purpose of the treatment and complicates the control of the individual chemical concentration in the boiler water. Individual chemicals are used for the boiler water treatment rather than ready mixed compounds because they are permanent better for the control of the concentration. Proper chemical concentration are not effective at protecting the internal water connected and attacked surfaces. Other boilers against scale and corrosion and chemical analysis boiler water should be made so that the chemical demand of the water may be determined with the water treatment. Requirements are described in 4.5. The solution of the titanium phosphate titanium dissolved in the hot water approximately 160 degrees Fahrenheit, 180 degrees Fahrenheit, and clean metal material still unturned until the titanium is completely dissolved. Mix sulfate separately in the water approximately 150 degrees Fahrenheit. Clean metal container and stir until all phosphates are dissolved. Mix two solutions before placing a chemical feeding device to the solution of caustic soda. Caution: do not use hot water with a solution of caustic soda. Splashing or possible serious injury will result. Wear goggles and rubber gloves when mixing the chemical. Do not pour the cold water on the caustic soda, as the splashing or possible serious injury could result. Add the caustic soda gradually and constant stirring to adequate quantity of cold water. 3. Solution in sodium sulfite. Mixing sodium sulfite is just before the use of the cold water with minimum exposure to the air. If it is mixed too soon, the chemical is useless with the boiler water treatment because of the reaction of the oxygen from the air which is dissolved in the solution. Use the minimum amount of the mixture mixing to dissolve the chemical. 412. Initial flushing and cleaning. Contracts and installation of new boilers generally require the removal of all foreign materials fouled with the initial boiling out of the period of the chemical solution. If the chemical cleaning is considered necessary for after accepting of the boiler, the following steps are below. A. Before the boiling out procedure has begun, replace the high pressure gauge glasses with temporary glasses to prevent attack with the glass by boiler out mixture. B. Chemical for the flowing proportion should be thoroughly dissolved with water before being placed into the boilers. 24 pounds of acidic, 24 pounds of disodium phosphate or anhydrous, 8 pounds of sodium nitrate, 1/2 pound of suitable wetting agent, 1,000 gallons of water. Her filling water with above solution operating with approximately 30 to 50 psi of gallons for a period of 24 to 48 hours, exhausting the steam to atmosphere, open the drain boiler and remove any loose material, flush boiler with oil, the ensure none of the chemicals used in the boiling out with the process remaining in the boiler, remove oil residual will cause them foaming in the boiler and water contaminating of the semen provided. Adequate blowdown during the first week of the boiler cooperation. Alright, 413, flushing and cleaning the scaled corroded boilers. Many used boilers are scaled with the corroded upon the installation. The corrosion appeared with the series, making the immediate boiler inspection. The scale is moderate with light and removed with those fouls. Clean all the loose scales and any scale adhering to the boiler, which can be removed annually. Place in approximately 15 pounds of caustic soda, 10 pounds of phosphate for each 100 horsepower with 3,450 pounds of steam pressure per hour. Boiler capacity. Seal the boiler opening to the opening. All the vents fill the boiler approximately 3/4 full with water. Use a small fire furnace with a raise for the temperature for the water with the boiler approximately 250 degrees. Maintain the temperature of 24 to 48 degrees. Add the makeup of the water required during the period of the fill with the boiler with base for the safety valves. Analyze the boiler water during the boiler out period with the iron caustic sodium phosphate to maintain the following concentrations. Hydroxide at 300 to 500 parts per million. Phosphate 100 to 150 parts per million. Open the boiler end of the boil out period. Clean out the sludge loose scale with the pay particular attention for removing the scale and sludge from the water legs. Fire tube boilers. Flush the boiler thoroughly. If at the end of the blowout period of inspection show that the heavy and the hard scale was not removed, the use of an acidic remove with the scale that indicated notifying the operating agency commander due to the hazard involved with the possibility of the damage of the boiler with the acidic cleaning large steel boilers using firm specialized in the type of the work. If the extensive corrosion is exposed when the scale is removed, the boiler inspector may be made appropriate to an agency. When the boiler is operated with the residual scale because of the faulty operation, sufficient frequent blowdown must be used to maintain the dissolved solid with a maximum 350 and 3,500 parts per million. Take the boiler out of the surface and frequently intervals remove sludge from the integrated scale. 414, sampling. Samples obtained and tested so that the treatment chemicals are maintained with the proper limit of blowdown can be controlled. The sample should be representative of the water to be tested. This can be accomplished by using the proper sample points and methods. All samples must be drawn before the chemicals are added to determine the minimum concentration of the chemicals available to the boiler. Samples must be drawn before the bottom is blowed down to determine the maximum total dissolved solids content of the boiler water. Sample of check analysis. Army Regulation 420 and 49 requires the samples to be submitted adequately and equip the laboratory for the checking analysis. Samples are submitted to assist operation personnel with the correcting faulty and analytical techniques and provide with the quality of the check reagents, making available the basic evaluation compliance with the residual requirement. The USAEHSC Laboratory, Fort Bellew, Virginia, performs checks and analysis on samples submitted to the Army Installation and Overseas Command, where shipment is sampled to the United States is not feasible. The expedition samples will be sent to the central laboratory established by the command. Report sample analysis are returned through the command and channels, including appropriate technical comments. 1. Each operating boiler plant equipped with the hot water steam boilers within one or more of the boilers, 3.5 million BTU per hour, or 100 horsepower greater than capacity, then submitted the sample to check the analysis of each month. Each operating boiler plant equipped with the hot water steam boilers less than 3.5 million BTUs an hour. The horsepower capacity should be submitted to a sample for the check analysis one every 3 months. 3. Submitting 32-ounce sample with a high-pressure 15 psi gauge greater than boilers, low-pressure boiler treated with the caustic phosphate, tannin, and sodium sulfite. 4. Submit 4 ounces sample low-pressure boiler with less than 15 psi treated with the caustic only. 5. Submit 32-ounce sample with the hot water boilers. 6. Sample should Sample shipping containers, bottles with the submission, boil water check of the analysis obtained with the direct request of the USA EHSC over the seas and air of the command established with the central boiler for the analysis of the boiler water sample. The container for the bottles should be obtained from the source. Containers for the high pressure boiler water sample are designed to ship the 32-ounce plastic bottle. Containers of the water sample from the lower pressure boilers treated with the caustic soda of the design and shipped in the 4-ounce plastic bottle. Placed the bottom bottle carefully through the will not leak in shipment. A dash should be enclosed in each sample container completely filled with the dash sheet and ship it with the sample. Water sample collection. Water samples should be drawn with the cooling coil to prevent the flashing with the boiler water system. Air cooled coil can be used in sample drawn slowly. Best results obtained with using the water cold, such as one shown in Figure 422. If the boiler water is taken out without cooling, becomes the concentrated because of the portion of the water flashes in the steam. Blowdown based on the testing of Figure 422 shows the water cooled sample. You have a line going from the boiler to the cap of the pipe with a 4-inch diameter of 24 inches height. With the boiler water sample, the cooling water line through the bottom, and the cooling water line through the bottom with 2 butterflies, one on the inside, one on the outside, with the water sample from the boiler to the waste, and the 25 inches to 24 inch, 25 inch by 3/8 diameter tube. Alright, concentrated samples will be highly resulting in unnecessary chemical engineering costs. It is important to flush the sample line of the cooler before taking the sample location sizing line. Using the manufacturer supplied sample connection with the provided water column connections may be used, but the sample connections are not provided with the blowdown water down column. Down several times, draws the sample from 1/4 inch sample connection installed with the head of the water column blowdown valve with the properly located but the continuous blowdown connections can also make the good sampling points. If the sample connection is close with the feed water line and measure for the sample diluted with the feed water pipe with all the simple connections with the floor level, conveniency of the safety connecting the sample order the sample line is desirable located with the sample cooler with the nearest laboratory sink as well, where the test and water residual are made. The steam sampling nozzle. The separate steam sampling nozzle desired to ensure the representative sample is obtained with an individual boiler. The nozzle's method of the contention should be conformed with the American Society of Testing Materials ASTM method D 1066. A sampler cooler other than one used for the sampling boiler water must be using steam sample because of the possibility of collecting residual boiler water solids and the piping connection valves conveying the steam of the sample cooler and may corrosion resisting materials such as the brass, copper, stainless steel, and the steam sample should be taken in the following manners. 1. Flush the sample line cooler through the flush of the new sampling equipment with 24 hours before the use of collecting steam samples. 2. Draw the sample slowly with the bringing it out with the 70 degrees Fahrenheit unless the test called for the higher temperature becoming the regulating of the flow of the cooling water. 3. Rinse the collecting container at least 3 times with the sample water before collecting the sample. Collect a pint or 500 milliliters of the sample thoroughly. Clean the glass container. Note that the sample drawn is velocity of the steam and main is high, more representative than the sample drawn of velocity below. 415 Chemical Analysis. The chemical analysis formed with the boiler water purpose to accurately determine the chemical makeup of the water. They accurately analyze the important step of the protecting equipment excessive corrosion scale of the scanning time, maintaining the most economical production of the steam and hot water. Authority for test kit analysis equipment provided by the Army. Regular use of each of the boiler. The equipped test must be developed by the boiler manufacturer, government, and chemical analysis laboratory, given the accurate time of information of boiler water conditions that unique each installation. Therefore, there may be other tests given the parameter of the boiler performance. However, a good general rule: if the equipment and the test procedure are not discussed by this manual, the test is not authorized, or the procedure must be likely to cost and time-consuming to perform on a regular basis, resulting on unauthorized testing can require an extraordinary level of training and proper preparation. B. Testing schedule. Tests should be run accordingly to schedule below. The procedure for these tests are outlined in Appendix B. 1. Boiler water. All boilers of 100 horsepower or more than tested daily. Boilers less than 100 horsepower are tested twice weekly. More than often necessary to maintain specified chemical limits. The high pressure steam of the boilers are tested with calicylic phosphate, tannium, sodium sulfide conductivity. Low pressure steam boilers treated with corrosion, caustic soda only tested for the pH conductivity. Hot water boilers are tested prior and daily for the pH hardness and solid sulfide, sodium sulfite. Low water temperature boilers are tested for nitrate. Both water samples of all hot water steam boilers are submitted to the USA EHSC laboratory for check analysis and intervals specified in paragraph 14.4a. 2. Condensate. Condensate is sampled daily with a return of the plan weekly at the end of the midpoint. The distribution system parameters are tested. pH conductivity. Hardness is tested and changed the conductivity. Notice routine hardness testing and submitted with the conductivity testing. Hardness indicates the leakage of the raw water system. Leakage must be found with the corrected 3. External treatment plants. Water samples for the external treatment sham should be tested in each for the operating unit with one of the frequently based with the manufacturer instruction of the parameter test for the hardness of the free mineral acidity, alkalinity, depending upon the particular equipment, the operation pressure for the temperature. Deaerator unit should be checked the record only to the shift and the add just made and is required. 3. C. Instrumentation. Instrumentation has been developed which can accurately, reliably, continuously monitor the conductivity of the boiler water. The instrumentation economic testing for the use of the concentrating steam blowdown system controlling the dissolved with the suspended with the solids during the daily test conductivity still required in reference paragraph 4.8d of the discussing conductivity meters. Alright, D. Special corrosion test. Corrosion testing assemblies installed with various points of the condensating system with a 3-month test period to study the corrosion test should be performed once a year in each of the condensating systems. The corrosion coupons, which are machined with the weight of the prior to the installation, are removed at the end of the test forwarded to the USA EHSC for analysis. Loss of height, thickness, and amount of the channeling and pitting of the mesh with the general appearance will be evaluated by the USA EHSC. The preparator of the reporting noting with the corrosion rates of the piping is tested with the recommended change of the water treatment and procedure. Reference figure 423 when it's shown with the corrosion test. The AHSC was supplied with the corrosion tester should be completely filled out and returned with coupons. 416. General operation of the external treatment equipment. Complete operation instructions for the external treatment of the equipment are contained with the manufacturer manual. The following information should not be regarded as a substitute with the individual manufacturer's instructions. Zeosulfite softeners. The proper operation of all softening must be manufacturer instructional conspicuous near the softening units. Follow these instructions by regeneration of the rinsing operation with these units. Keep the careful record of the consumption of the softeners. Periodically compare the consumption specified by the manufacturer's salt consumption per unit volume. Soften with the extent index of the softener performance. Increase the quantity of the scale salt between the regenerations of the giving unit indicates a deterioration of performance. 1. Rate of flow. Rates of flow. To obtain the continuous satisfactory performance of the zeolite treatment, the equipment, the essential flow rates maintained within all type of the limits set by the manufacturer. Figure 424 illustrates the schematically normal up-down flows of the zeolite unit. The downward flow represents the surface regeneration solution rinsing the flows, and upflow represents the back flat wash. Alright, A. Surface flow. When the recommended surface flow rate exceeds the excessive pressure of the drop, loss of the impurity, remove the efficiency of fluid, then there are results of the forcing water of the channel throughout the path of the least resistance of the softer material, thereby reducing the necessary contact with the zeolite. Reference figures 425 will illustrate the effect of the excessive flow rate. Backwash flow. In operating with a zeolite bed based on raised with the individual grains of zeolite are suspended in the water packing in the bed, which can occur during the surface operation is broken up in dirt and other foreign material that may be collected on top of the bed is washed out, and if the backwash rate is too low, backing the broken up of the zeolite bed is not properly suspended. Under these conditions, fine foreign materials, dirt, and not washed out of the bed. Fine particles are not washed out of the bed. Acts of the abrasive on the zeolite grains. The abrasive action may cause the zeolite grains to break up, then leading with an increase with the pressure of the drop of the break through with the subsequent washing. If this occurs, the entire contents of the unit may be held with have to be removed. The gravel regraded with the bed relayed. Backwashing is an insufficient rate of flow over the extended period of during does not accomplish the desired result because even though the water waste appears fairly clear, only the dirt and fume fines Only dirt and fine fumes capable of being lifted with a low flow rate are removed, while other objectionable heavier particles remain. If the wash rate is too high, the zeolite washes out, reducing the capacity for the unit. Backwashing for too short of the period does not complete the operation because of the minimum length of time and the volume of the water required to lift the zeolite before the zeolite finds the form material are removed. The backwashing is too long period of the proper rate. The flowing rate wastewater care must be taken to avoid sudden shocks bed while backwashing. Shocks may be caused with water entering the unit rapidly by pumps being started with the unit by inches backwashing by bubbles entering into the unit. Any of these may cause gravel hills and upsetting the bed. See regenerate solution flow. An operation of the impurities attached with the combined with zeolite or removed zeolite is reactivated, passing the regeneration solution through the bed. The solution can enter through a distribution laterals at the top of the unit base, passing through the bed and leave the bottom. Its strength whether made with brine, sulfuric acid, caustic soda, and most important, the manufacturer's instruction preparation must be followed. If the proper solution strength and solution volume is maintained, the unit will operate with reduced capacity. D. Rinse flow. To obtain the correct rate of flow, the rinse flow control device must operate fairly by the adjustment in accordance with the manufacturer's instruction. If the rinse rate is too high in the bed, it tends to pack. If the rate is too low and the rinse time is prolonged, or the excessive regeneration solution impurities are not properly washed out. To check for efficiency after the zeolite unit has been installed, the installing contractor will test the performance quantity of the shredded water with the unit that can deliver the easy check with the exchange with the capacity number of the cubic feet of zeolite combined with the softening unit is known. For example, this shows the 423 condensating corrosion tester. This is zeolite softener water flow. It shows the normal backwash. Your effective wash flow rates. You should see the arrows going down. Alright, alright. Where did I go here? Our capacity in gallons is equal to cubic feet of zeolite times the exchange with the capacity of zeolite in grains per cubic feet over the hardness of water and the calcium carbon calcium CO3 grains per gallon. And sodium zeolite units exchanged with the capacity of 250,000 grains of raw water has hardness of the 10 grains per gallon with the unit softener of 250,000 times divided by 10 and 25,000 gallons between regenerations. If the unit requires regeneration after the softening of 200,000 gallons of the same 10 grain hardness water, the unit efficiency of 200,000 over 2,500 20,000 over 25,000 times 100 is 80%, but the raw water analysis change with such hardness does not increase to the 10 grains to 12.5 grains, and then the 20,000 gallons softened between the regeneration shows no less loss efficiency of 250,000 and 12.5 to 20,000 gallons. It's necessary to check the softener efficiency periodically. If shows the marked decrease, the operator should go through the foregoing procedure, determine the loss efficiency due to the change in raw materials analysis. If it's due to the other factor, the flow rate during the surface regeneration should be checked to determine the recommended areas. Determine if the recommended rates are being properly maintained. The surface of the zeolite should also be checked for the hilly preparedness of the given evidence of channeling, packing in the bed, furnishing the clue with the condition of the gravel bed, furnish the surface of the beneath, the check of the depth of the zeolite bed, furnished with the dew condition of the gravel bed, surface beneath, the check of the depth of the zeolite bed indicates whether the zeolite has been washed. Measures should be taken at several points to ensure the average depth that they are inserting a small diameter rod with a 6-foot metal rule throughout the zeolite unit with the gravel is felt within, noting with the distance of the rod and rule was inserted to make the probings and approximately the point indicated in figure 426. Enter the measurement corresponding circles. Another way to determine the depth is comparative measurement. of the distant zeolite surface of the backwash from the brine distributed with the fittings and some other fixed points. If the loss of zeolite material is evident, the cost must be found with the zeolite replenishment, which care can be taken to avoid repetition of the loss. In addition to washing out, the loss may be caused with a defective undraining system or backlogged defective brine distributor. In other causes may be exchanged with water to undergo treatment consistent with the incompatibility of zeolite beginning use. In this case, the failure cannot be determined cause all the manufacturer service representative on the maintenance recommendation failed. The corrective operational difficulties refers to matter of operating agency commander. 3. Check all salt requirements. Approximately 1/2 pound of salt is required per 1,000 grains of hardness to remove each of the generation following calculation. It is to determine actual salt consumption. Salt is required in pounds equals to gallons of water softened times hardness of the water as in sodium or calcium CO3 in grains per gallon over 2,000. A saturated solution of brine necessary to proper regeneration softening unit. Presume barium gravity of 23 degrees, containing 2.5 pounds of salt a gallon. Parallel operation. The best result, the most efficient operation obtained within the the units operated within parallel regardless of the load imposed with the softening plant, but all the units should be operated simultaneously if more than one softening is used to install the plant of the regeneration of the unit should be staggered. B. The hot process lime sodium sulfide in the operation hot process plant, but the following minimum requirements for proper preference must be carefully observed. 1. Steam pressure and temperature. A positive steam pressure must be maintained within the reaction of the sedimentation tank with all times ensuring the ventilating of the oxygen over non-condensable gas and minimum water with the temperature of sediment tanks must not have been more than 5 to 10 degrees Fahrenheit below the temperature of the steam in the tank. The temperature is necessary to promote softening reactions to ensure the complete setting of the participates in sufficient exhaust steam is available to maintain the temperature of the live steam that must be supplied with the control of the steam space so that the positive pressure is maintained within the tank. Chemical control test. The chemical test must be made regularly in accordance with the manufacturer recommendation. Satisfactory result cannot be expected, but the operator can be certain at all times that the water is heading everywhere in the plant with the best quality obtainable. 3. Chemical tanks. Chemical tanks must be charged regularly with the correct amount of the proper chemical to the time of the charging of the operating. Must exchange the proportional equipment to ensure that moving the parts operating freely. Sludge blowdown. The sedimentation tank must be blowed down regularly with the frequent depending on the characteristic of the raw material. If the practice is not followed, sludge cone filled with the sludge and the excessive amount of the sludge suspended matter can be carried up into the clarified water zone, overloading the filters. Filter backflash. Filter must be backwashed regularly with ensure the ample hydraulic head of the booster and the boiler feed water pumps. Proper backwashing will also help prevent suspending matters accumulating with the point which passes through the filtering material that contaminates the feed water. Alright, figure 426 shows the zeolite bed installations, back, left, right, front. Measurements are entered in the circles, and small circles indicate where the probing may be made with the zeolite bed depth. Or 6. Overload. To assure the proper operation with the softener and filters provided with the high-quality boiler make up the rated capacity, the softener must not be exceeded. Deaerators. The operating procedure for the efficient deaerators involved with keeping the deaerator vent open at all times, keeping the live stream regulator on all times, using as much exhaust steam as possible, maintaining the water boiling temperature, keeping the makeup of the water with the minimum cleaning of the deaerator less than every 6 months, checking the train operation with the oil separator daily, checking the surge tank of the deaerator overflow of the leak valve. The reasoning of the actions are prescribed in the following paragraphs. It is important properly located with the calibrated thermometer and pressure gauge that are to be installed with each of the deaerator. Only with the accurate temperature pressure information is proper deaerator operator possibility. 1. Relationship of the temperature, pressure, and solubility. In order to preserve the good deaeration temperature of the feed, water must be continuously maintained with a saturation temperature corresponding with the steam pressure maintained with the deaerator. The proper relationship between the water temperature and the steam pressure is shown there, table 4 or 5. The difference between the saturation temperature is corrected for the altitude, and the feed water temperature should not be more than 1 degree. A, for example, assume that the following conditions: a boiler plant located in an elevation of 1,000 feet above the sea level with a steam pressure of the deaerator of 2 psi of gauge for the feed water temperature of the heat water storage compartment at 216 degrees Fahrenheit, indicated the table 4.5. The temperature deficiency is not more than 1.1 degree Fahrenheit. Therefore, the heater is efficiently removed with the dissolved gas. Say for the example, to merely maintain the temperatures above 212 degrees Fahrenheit would not give the deaeration, since a significant amount of the oxygen may still stay dissolved in the water. Right, for example, the solubility, assuming the following condition: the aerator is operating with 7 psi gauge of the pressure of the feed water temperature of the 818 degrees Fahrenheit, but the following temperature line figure 4 is 27 and 200 for 212 degrees Fahrenheit vertically uprose with 7 psi gauge with the pressure curve intersection, and then moving the left of the oxygen content table in the zone of the suitability oxygen under the conditions 1.8 cc per liter of 2.5 parts per million of the cc oxygen per liter of the 1.4 parts per million oxygen. Too high increase indicated adequate deaeration. Good deaeration should reduce the oxygen between 7 to 40 parts per million, 1,000 times less than example. The assumed good deaeration, the proper feed water temperature of 7 psi steam pressure is found to be at 233 degrees Fahrenheit at sea level. This must also be remembered that adequate vent of the lobe must be maintained with optimum deaeration to be accomplished, so see paragraph 3 for further information. 2. Methods of maintaining temperatures. All possible exhaust steam should be used through the deaerated operation. When the large amount of the exhaust steam is available, the boiler plant is to lower such fans, turbines, strokers, pumps, and the back pressure should be set. The high particular insulation will permit without causing feed water pump and trouble. Temperatures at 230 to 240 degrees are not usually type of the operation. Live the steam regulators, reducing valves are used to supply the necessary steam. When sufficient exhaust steam is not available, they should be keep turned on all times because the steam is only as required live steam. The deaerator can be controlled by the hand due to fluctuating loads. Such procedure would cause either too much or too little to be used. Proper deaeration requires the proper amount of steam at the right time. Live steam regulators must be properly sized and controlled. Heavily intermittent loads will require large regulators that steady the load when necessary. To install load regulator for more capacity to handle the occasional intermittent load. A smaller regulator should be installed in parallel with a large one. This will provide a better control since the large one can be shut down in periods of light load, such as summer session. Large regulators have a tendency to charter over the sea. Generally do not control well very little loads. Regulators on top of to give the closed control pressure range of 1.5 to 5 psi gallon psi. The gauge should be installed. The general calls for a large diaphragm of 12 to 16 inches diameter of the pilot control valve. The regulator should be installed with their outlet and as close as possible. The deaerator and outlet lines should be normally increased with large line size. Long line from the regulator to deaerator should be avoided as the slow reaction of the regulator given the poor controls. The control line of the regulator should be piped directly to the deaerator shell. Since the pressure of the control in the deaerator, not in the line, the deaerator instant action regulators are required to ensure the steam that provided instantly with the deaeration taking place with the water flow of the deaerator. This response can only obtain with the regulating sensing line. Actually, sense pressure of the obtaining deaerated shell propeller control lines connected closed and lines and regulator for the lines are not effective. 3. Venting of gases. Gases that are released from the water gases that are released from water must be properly vented. Failure to obtain proper water temperature is often due to the insufficient venting. This can be done with 2 ways: directly with the atmosphere through the vent condenser to the atmosphere, the vent directly with the atmosphere, effectively both resulting in the wasted steam. Venting through the vent and condenser is better since they must be heat and then the vent steam is recovered. 4 or 5 shows the deaerated temperatures of the versus pressure. You have deaerated temperature pressures, increments of 500ths from psi and pressure in a heat gauge, sea level at 212, and the boiler points corresponding with the various elevations of 5, and increments of 5 to 500 to 600, 500 from sea level to 6,000 feet above. Alright, your oxygen content cc per liter, and your vacuum in mercury, gauge temperature, pressure, and gauges 0 to 16 oxygen cc per liter, 32 to 250 temperature in degrees Fahrenheit. Conventional heaters are vented with either the top or the side of the shell with a thermostatic strap that should be not used for the best vent with the heater with 1.5 to 3.25 inch gate with valve within 1/8 of an inch hole drilled with the C of the permitting the positive venting at all times case for the valves and inadvertently to close with the amount of the valve opening dependent on the load conditions inside of the heater. Approximately 1/10 of the 1% of the permanent plant load is usually required to be vented at all times. Actual amount required of the trial and error determination series, the oxygen analysis of the water of the deaerator, oxygen content of the water's final criteria for the proper deaeration vent line should be installed to permit the visual observation of the amount of venting. D. Correction of the improper deaerator operation. Operation of mechanical exchange to correct the deaerator troubles or describe below change. They should be made with a systematic step-by-step procedure because more than one may be corrected adversely a condition. 1. Surge tank problems. Surge tank problems may occur when the water tendency to hold the tank. A. Installation vacuum breaker that closes the surge tank when under the pressure. This can be 1 to 1.5 inches, 2-inch flapper type, the check valve. Vacuum sometimes caused with a sudden heavy load with the cold condensated with the raw waters enter the hot storage tank. B. Lower the pressure maintained with the deaerator operated with low pressure required with the uniform temperature control. C. If the surge tank is constructed for the pressures up to 15 psi, gauge for the condensated return pump discharging this sufficient head of the capacity and equalizing line may be installed between the top of the surge tank of the deaerator, maintaining the same pressure of the both. Install line with the ample size of the equalizer pressure 4. Install the feed line with the ample size between the surge tank of the deaerator. Streamlines or much as possible fitting of the turns which could be retarded as retard the flow. E. Where the headroom permits the condensated return pump with the sufficient head capacity to breathe with the surge tank to provide at least 3 psi dynamic head. The difference between the water level and the surge tank at the top of the deaerator. For example, the deaerator operating at psi of the gallons will require that the surge tank water level be at least 3 psi gallons to 3 psi gauge to plus 3 psi plus times 2.31 feet per psi or 3.58 feet above the water inlet of the deaerator. Consideration must be given when the friction along with the straight piping, the fittings as well as the control valve and the type of the vent condenser, the type of the deaerator to arrive. Proper height of the surge tank when the equalizing the lines usually made between the surge tank and deaerator. Minimum distance of 3 psi times 2.3 feet per psi or 6.93 feet. With an insufficient head between the deaerator boiler feed pump, then it would be uneconomical to raise the deaerator and install the low head to bolster pump between the deaerator feed water but to prevent vapor binding. Selecting the pump adequate with the capacity discharge pressure sufficient to maintain 3 psi dynamic head of the suction side of the feed water pumps while the low capacity of the plant. 2. Lacking adequate head of the boiler feeding pump. Adequate head of between the deaerator between the boiler feed pumps is only one of the common source of the trouble. A. Check the feed pump, the proper packing, the valve setting, the slippage. For reciprocating pumps, when normal operation, use the pump at the high rate when the two pumps are lower speed instead. This will give the cylinder more time to fill, thereby decreasing the tendency for the water to flash. Install a vertical storage chamber within the suction side of the feed pump. The chamber should be constructed by the pipe of 1 or 2 sizes larger than the pump suction, equalized with the heater running with the 1 1/4 inch line at the top of the chamber of the steam space of the deaerator. D. 1.5 3/8 inch line may be run from the top of the water cylinder to the feed pump. The head got bleed cock through the steam space of the deaerator to act as the bleed line for the any-stream vapor form. This is especially useful in centrifugal pumping. Piping connections between the deaerator feed pump should be directed in possible ample size, at least one of the size the larger of the pump inlet. Any of the reduction size should be made in the pump inlet and avoid numerous fittings with 90-degree turns. 5. Lower operating pressure deaerator pump as much as possible must be allowed to operate some of the continuous positive pressure. Eventually is only 1/2 inch psi gauge. Only 1/2 psi gauge. The aeration is only successful the temperature above the boiling water pressure, which can only occur if there is a positive pressure of the deaerator. Alright, G. When construction permit to give the conservation possibility to lower the boiler pump feed, the pit, and the raising of the deaerator in order to obtain the necessary head of the pump suction, this should be considered only after all the means of correction has been exhausted. 3. Feed water temperature fluctuation. If the feed water temperature varies widely with the expected as given the self conditions, one of the following problems exist. The deaerator must be insufficiently and properly vented. The thermometer pressure gauge must be interacted and check the instruments with the accuracy. Pressure gauge readings must be corrected. Hydrostatic head, and if any of them may correction plus 0.3 psi, 0.4 plus a positive 0.43 psi for each of the heat foot of static head due to the water leg. For example, the gauge installed within 10 feet below the level of the gauge connection of the heater would require the correction of 4.3 psi or 6.3 psi gauge reading minus 4.3 psi equaling 2 psi in the deaerator. The shell of the deaerator is most satisfactory location for the gauge installation. D. The deaerator may require cleaning. The deaerator trays must be misaligned. Thermometer bulb may not be submerged in the circulating water. If it is important for the bulb being submerged about 4 inches. If the bulb is out of the water, it will measure steam temperature rather than water temperature proper to control impossibility, and proper control will be impossible. See, the deaerator may not be sufficient capacity for the amount of the water being heated. The live steam supply must be insufficient. I. The pressure regulating valve must be misadjusted in proper side within the closing control. Alright, 417, General Operation Internal Treatment Equipment. The boiler water treated with the corrosion and scale of the deposit of the boiler water distribution system internal treatment chemicals should be maintained with the limits established in paragraph 4 or 5. The failure to maintain proper treatment levels can result in excessive corrosion and scale of the tube failure, leaks and injury loss, excessive maintenance, operating expenses, chemicals and feed equipment used in internal treatment discussed in paragraph 4 to 8. The feeding procedures and precautions are discussed in below. The chemical feed equipment. The internal treatment of the chemicals can be fed with a system that will either closed with the open feeder of the steam boiler or operating with a 15 psi gauge should be provided with equipment to aid the chemical directly to the boiler. The point of the chemical adhesion admission varies with the specific chemical for the individual boiler plant with the operating conditions used in the chemical feed connection provided with the boiler manufacturer possibilities. 1. The closed feeder. The pressure pipe feeder is a simple chemical feeder that can be fabricated from a piece of a 6 by 8 inch pipe with an 18 to 24 inches long, both ends of the seal with the cap and the welding. Suitable valve with the funnel heads are installed in the emission discharge feeders fabricated in accordance with the American Standard Mechanical Engineering Code are commercial with the available military specification MIL-F 18113. Show of pressure pot feeder within illustrated figure 428, both entering the pressure pot feeder with the chemicals most mixed dissolved in the mixing tank. For the small insulation mixing tank may consist of a steel gauge and a steel barrel and a small steam jet with the bottom of the mixing tank can be also used, facilitating the mixing chemical such as phosphate titanium dissolved with fine mesh pellet back at the suspending justice beneath the surface of the water and mixing tank. The figure 429 illustrates the most elaborate dissolving tank operation pressure. 2. Open feeder chemical mixing tank chemical feed pump. For large chemical dosages, is more convenient to open the feeder with a chemical feed pump than shown in figure 430. The use of the arrangement is usually justified with the boiler for the use of the measurement of $1,000 worth of chemical per year because it improves the result to reduce the chemical cost. The chemical dissolving tank should be large enough to hold 1 per gallon per solution of each of the pound chemical used per day. Move the commercial chemicals mixing tanks is made with the fiberglass, although the main insulation of the 55-gallon drum is suitable with the tank should not be made with a galvanized tin but the iron or the aluminum. Open feeder has been valve line near the bottom of the carry the chemical solution of the pump. The gauge is glass agitator, safety relief valve, the cover and the screen of dissolving basket suspended with the point of the foot below the top of the tank. Donut floats should not be used with sodium sulfite and prepare with avoid oxidation of the solution. No direct connection between the potable water supply and chemical tank is permitted. Figure 431 illustrates plunger at diaphragm type of which suitable chemical feed applications. B. Feed procedures. Chemicals should be fed after the making of the test of the boiler water chemical residual. If the test and totally dissolved solid indicates the blowdown is necessary. The blow of the boiler down before the feeding of the chemicals to certain residual or low pressure lows proceeds as follows. Determine the required amount of the treatment chemical study with the chemical residual test result of the boiler operation 2. Weigh the total amount of each of the required chemical. 3. Dissolve the chemical in mixing, dissolving the tank and adding sufficient water, but the use would in pain will reserve the purpose. 4. Allow the solution to flow in the chemical pump to replace with the pressure pump pot feeder in proportion to the requirements of each of the boiler. When only one boiler is involved, all the required chemical solutions must be mixed for bed as a single solution. When the feed water deaerator is installed, feed sodium sulfide continues to the reserve of the heater of the deaerator. Feeding precautions. When feeding chemicals, using the following precautions: do not feed any chemical ahead of the feed water heater or deaerator. It shows the pressure of the pot feeder. You have a you have your 5-inch diameter, 3¼ inch valve, 3/8 inch air cock with a control valve on 3/4, with the shutoff cock of the 24 inches of 5/8 inch gauge glass 8-inch tube, 2-inch control valve, 2-inch nipple and discharge, and a 3/4 inch drain. Or your automatic proportional feeder. Or you got your orifice lift check valve. These go for the corner open and forth on the inlet mixing tank overflow medium red of indicator feet valve, pressure feed tank gauge glass, 3/8 inch water supply, 3/8 inch steam, and their size and dimensions. 430 shows a chemical mixing tank with a chemical feed pump. 431 shows a chemical feed pump with a plunger diaphragm type. All right. 2. Do not feed sodium orthophosphates unless authorized by operating agency commander. Not feed sodium orthophosphates into the feed water system. Feed it directly into the boiler. Never place dry chemicals on the chemical feeder or pump. If the practice will plug the chemical feeder line for a short time. Make sure all the piping, the valves installed with the chemical feeders or pumps are designed with the standing of the boiler pressure. 6. Drain the feeder before introducing the chemicals. Drain feeder with all the pressure connection with the feed before the boiling the drain to prevent the injury of the operator to the hot water chemicals. 418. Safety precautions. Primarily requirements the safety of the boiler plant water conditions, the same as for the operating of any other plant process. Good maintenance, proper procedure, good housekeeping. If the plant is not kept clean, orderly with the chance of the accidents, multiple with the treatment of the water involved with the use of the chemicals, some of which are dangerous if not handled properly. Also, safety data should be thoroughly read but strictly fouled. Acids. The test for the chemical residual individual negligible quantity for the acid resistance of small slippage village and avoid with the bottles containing the acid are not broken. Greater risk involved with the handling of the sulfuric acid and hydrogen zeolite demineralizing direct acid treatment process. Manufacturing Chemists Association has been published chemical safety data sheet with SD20 dealing with the methods of handling sulfuric acid following the exemption experts from the bulletin list some of the recommendation precautions. 1. Do not permit the dilute and strong sulfuric acid to come in contact with the eyes or skin of the clothing. When handling the acids, always wear goggles and face shield gloves and protective gloves. Never add water with the colistitic solution with sulfuric acid. Violent reactions can take place, and splattering must be avoided. If necessary to mix the acid, always add continuous closed water, but never add the strong acid. 4. Cleaning and repairing of the tank should be performed under the supervision of the foreman. Instruction relatively entering the cleaning of the tanks is next step of the tanking must be instantly observed. Emergency equipment must be immediately available before workers are allowed to enter the tanks or making repairs. Wash down spills immediately with plenty of the water. Never use combustibles such as cloth or sawdust or other organic materials for the mopping up of spilled sulfuric acid. Alright, 6. In the event of accidental contact with all contaminated clothing should be removed immediately. Affected areas washed in plenty with water for at least 15 minutes. This is especially important with the eyes or when the eyes are affected. Colistitic soda. The Manufacturing Chemists Association has issued the chemical safety data sheet SD9 on the handling of the caustitic soda with the following quotation from the illustrate the need for the safety measurement. Caustitic soda is dangerous and improperly handled whenever the solid form of the solution made of the corrosive action result from the contact of the issue with the body. Since the sign of the symptoms irritation with the frequent do not evidently immediately after contact with the caustic soda, the injury may result with only one real life of the chemical is in contact with the body. Therefore, adequate protection against this exposure should be provided with all parts. If this precaution of ignored carelessness is tolerated, caustic soda is capable of reducing serious injury. The same precautions measure indicating sulfuric acid also apply to the handling of the caustic soda. First aid. The following safety equipment should be readily available Eye washing fountain. The eye washing fountain detailed in 432. The ready source of the running tap of the water such as the bubbler drinking fountain in the house, or with a soft and gentle flow of the water available to eye irrigation. Even though the minute with the quantity of the sulfuric acid and caustic soda entering the eyes irrigated eyes immediately flush the eyes with a large amount of water to minimum of 15 minutes. Safety shower. That has readily accessible wall marked down rapid action safety shower available to areas where the sulfuric acid caustic soda is being handled with such a type of the figure 433. Safety inspection. Inspection of all the safety equipment regularly ensure the working condition of all times. Place clearly marked inside the nearly emergency eye wash fountain and the safety showers, indicating the methods for the use. D. Chemical spill kits. Each of the boiler plants should be equipped with an appropriate chemical spill kit. These kits are commercially available to clean up kit, acids and base and solvents. This must be prepared before the spills, other than never happened. That never happened in the moments after the spill has been occurred, out not in time to decide how to handle the spill. 419. Care of the idle steel boiler. Serious condition caused by the oxygen dissolved in the water can occur with the boiler if it is idle. If the oxygen is permitted to dissolve in the small pools of boiler water and concentrated with the localized corrosion will result. It is not always possible to eliminate the boiler out of its own possible to dry. All right, this shows your eye wash station. You have here another safety shower. Alright, the boiler and following other procedure will protect the metal surfaces of standby boilers when be called upon to resume the operation within 4 to 6 hours. Under these conditions, it is not practicable to drain the boiler, and any alternate water method for the boiler layout with the recommended note that the dry method should not be used on cast iron. The boiler. The following procedure will protect the boiler metal against the corrosion during the outside service period. 1 to 3 days. Boilers that will not be used within 1 to 3 days that should be maintained with a hot standby condition. Steam boilers should have their outlet valve with the shut. The sludge should be blown down before shut down combustion equipment. Combustion equipment should be fired needed to maintain the proper under pressure to take care of, to not allow the boiler cool or pump pull a vacuum that would draw air to the boiler, damage the gas in normal boiler water treatment limits are maintained. 4 to 30 days, the boiler should be filled with the water pre-treated with the caustic soda and the sodium sulfite. See the procedure. 30 to 150 days, boilers should be laid upon the either wet or dry method. Wet is procedure, dry as procedure C and D. In excess of 150 days, the boiler should be laid up with quick lime or silicate gel method C procedure D. A. The wet method short period of the procedure of an A load condition may be necessary to shut the boiler down relatively short periods, yet maintaining the standby condition. Corrosion will result in the normal water level of the boiler maintained during the standby period. Procedure is followed to avoid corrosion. Approximately 1 hour before taking the boiler offline, introducing enough caustic soda with the sodium sulfite, increasing the caustic with approximately 500 parts per million hydroxide and provide 200 parts per million sodium sulfite concentration. As in when boiler is offline, fill the complete with the aerated water condensation. Before operating, resume with the drain water to the proper level to make the chemical test of the caustic porosity, containing total dissolved solids below down of the boiler. Feed the chemicals indicated with the test result. B. The wet method procedure. B. With the boiler is not on the standby surface of the dwelling. Wet layup. The main method is recommended. Drain the boiler completely. Ensure the water walls and gauge columns are not overlooked. Next, open the boiler and wash the inside with a low scale and sediment flushing thoroughly with the strong water pressure. The use of the sift brush and the clean water. All the internal surfaces of the boiler then can be reached with the breaker. The feed water steam the connection for the boiler and blank with the connection if in other Boilers are operating if the boiler plant is equipped with a deaerator filled with the boiler with a deaerator water. If the deaerator is installed with either containing the raw water, but the purpose of the boiler is filled with enough of the caustic soda to give the hydroxide extent of 500 parts per million with the boiler water, with about 8 pounds of caustic soda per 1,000 gallons, holding the capacity of the boiler even over the sodium sulfide, which gives 200 parts per million concentration, about 2 pounds of the sodium sulfide per 1,000 gallons should hold capacity of the boiler. To start a small fire in the furnace, open the vent and scent valve of the boiler, boil the water within the boiler under the atmospheric pressure for 2 hours to ensure circulation, chemical deaeration of the water of the boiler that has cooled with the fill of the boiler on the tip of the top, overflowing the vent with the safety valves ensuring the complete filling. For making periodic inspection to ensure they maintain the water level, replace any water lost from the boiler, to replace the necessary under these conditions additional chemicals to the boiler, maintain hydroxide sodium sulfide concentration of 500 parts per million, 200 parts respectively. 5. Facilitate inspection small tank equipped with a gauge that can be installed above the top of the boiler, as shown in Figure 434. The tank will then be filled with water connected with the steam takeoff the tap of the vent and safety valve connections. Again, that's the water level with a small drum that will quickly tell whether or not the boiler is completely filled. Dry method. Procedure C. The boilers equipped with the vent holes may be laid upon 50 to 150 days using dry method described below. 1. Take the boilers out, serve the drain completely with the steam water, ensure the water walls and the gauge columns are not overlooked. Next, open the boiler and wash inside with a loose scale sediment by the flushing through the strong water pressure using the shift brush. Clean and all internal surfaces of the boiler can be reached. Break the feed water on steam connection with the boiler and tank on the blank connection if the boiler and plants are operating. 2. If the boiler room is dry and well ventilated, the boiler may be left open to the atmosphere and is not used procedure D. D. Quicklime silicate gel method. Procedure D. This method applies to all the only boilers equipped with manholes. To take the boiler out of the surface of the drain completely with still water, can ensure the water well so the gauge columns are not overlooked. Next, open the boiler and wash from inside with a loose scale and sediment by flushing thoroughly with a strong water pressure. Use a stiff brush. Clean the internal surface of the boiler and blank connection with if the boiler and plant of the operating start the very light fire with the furnace. Maintain the fire at least 2 hours until the inspection showed no moisture in the internal section of the boiler. 3. Placing QuickTime hydrant liquid silica gel one or more metal with the fiber tray with the boiler. Place the trays in the wooden blocks so that they can be circulate beneath them. The amount of linear silica required is about 50 pounds per 30,000 pounds steam per hour boiler capacity. Note it is important that the quicklime and the silica gel does not contact with the metal surface of the boiler. 4. Seal the boiler tight. Open the inspection of the boiler every 2 months and carefully reseal immediately after the inspection. If this lime or silica gel is found to be wet upon the inspection, replace them with dry material. Resume operation. Reopen the boiler. Remove the trays, quicklime and silica gel. Reseal all the drum heads and manholes. Replace all the piping removed by blank. Alright, this shows Figure 434 shows the west storage method as any suitable boiler drum valve, small seal drum, water level. Chapter 5, Inspection and Preventive Maintenance.